I was asked for help on a problem from section 7.2 about finding the area under the standard normal curve given specific z-scores. So I'm going to talk about that a little bit. Okay, before I show how to do this calculation in StatCrunch, I just want to remind you from chapter 3, you were told about the empirical rule, which basically says the possibility that your data is going to fall within a certain number of standard deviations from the mean when you have the normal curve. So if you're one standard deviation from the mean in either direction, then 68% of the data will lie within plus or minus one standard deviation from the mean. So the empirical rule is an approximation. But when we look at the standard normal curve, we can find a more accurate probability likelihood of your data falling within a specific area of the curve based on its z-score. So in order to do that, we want to open up StatCrunch and take a look at the standard normal curve. So we do that by going Stat, Calculators, Normal. So it defaults to the standard normal curve. The standard normal has a mean of 0 and a standard deviation of 1. If your data has a different mean and standard deviation, you would type it in, and then the curve would still be a normal curve, but it would be set up based on your mean and standard deviation. So with the mean of 0, that means the center of our curve is 0 and a standard deviation of 1. So if a standard deviation of 1 is here, that means this is, again, between -1 and 1, we should have about 68% of our data falling within that region. We could actually even figure that out by doing between here. And so we see when we go between -1 and 1, it's not 68%, it's 68.268949%. So this is a really handy calculator for you. So for the problem that I was asked about, it's asking about the area under the standard normal curve that lies to the left of these specific z-scores. So we won't do between, we'll do standard. And then left would be less than or equal to. If it said right, you would just change this to greater than or equal to, but it's asking about the left. And since it's asking for the z-score, we put that in here. So that's -1.01, and click compute. And so the area under this curve, remember the total area under the curve is equal to 1, which is 100% likelihood that the data will fall somewhere under this curve. But if we are 1.01 standard deviations away from the mean, then the likelihood that our data falls in here is 15.6%, but we'd write it as a decimal here. And again, look at the number of decimal places that it's asked for in the problem. And so for this problem, it's 4 decimal places. So 0.1562. I hope this helps.